Bismillahirrahmanirrahim. Let's begin understanding dual. Basically, linear programming problem can be analyzed in two different ways, but would have equivalent solutions. So dual implies two or double. So any linear programming problem can be made dual, that is double or two. And the linear programming problem can be solved in multiple ways, like graphical method, simplex method. So whatever results comes in the graphical method, in the simplex solving will be same. So equivalent solution would come. So it is one of the ways to have the dual mathematical function. Let's begin solving the question first. For the following linear programming problem, maximize zx equals to 3x1 plus 5x2 subject to constraints are 2x1 plus 3x2 less than equals to 8, x1 plus 2x2 less than equals to 5, and x1 x2 greater than equals to 0. So this is basically a linear problem, and it is called the primal. It is called primal. So you see, primal is the linear mathematical model. Okay, and whenever you come across any linear problem, you have to validate the linear mathematical model into a canonical form. So primal has to be converted into canonical, and canonical into a dual form. That's how it goes. So the question arises, how do we get to know that this is a primal or canonical or dual? So we need to, whenever we come across any problem, so it is the most raw form of any mathematical model. So whenever you make a mathematical model of any linear problem, so it is called the primal. It is called primal. It is called primal. So you see the primal. So primal has to be converted into a canonical, or it has to be validated that whether it is canonical or not. So there are few important aspects of canonical. One is whenever there is a profit maximization function, it has to, in the canonical, it has to be constraints of the maximum profit maximization function. Constraint must be less than equals to, less than and equals to. And whenever primal function is in the minimization problem, in the minimization function, so if the primal is in minimization, it has to be in the greater than and equals to. Okay, so I am repeating myself again that in the primal, whenever the objective function is maximization, the constraints inequalities must be less than equals to. And whenever the primal function is in minimization of cost, so the constraints must be less, not less than, but greater than and equals to. Okay, this is very important. When it is done, so you have to convert it into other dual form. So in the dual form, the maximum profit maximization function has to be converted into the minimization of cost. Converted into minimization of cost. Basically, in duality, we see we try to find out the both ways. One is to minimize the cost or maximize the profit. So when you minimize the cost, it is basically equivalent to the maximization of profit. So when the cost is reduced, the profit is maximized. So you see over here, the profit is being maximized. Over here in the dual form, the cost has to be minimized. And whenever the cost has to be minimized, the inequality must be greater than n equals to. And in the second form, when the cost minimization function is in the canonical form, is in the primal form, then it has to be converted into the profit function. Profit function has to be, the constraint inequalities must be less than n equals to. Okay, let's summarize. In the primal form, it is the most raw form. When there is a cost function is given, when there is a profit function is given, in the primal form, when the profit function is given, it has to be converted into a cost function. Okay, it has to be converted into a cost function. So when it is a cost function, it is minimized. When it is minimized, the inequalities must be greater than n equals to. The constraints inequality must be greater than n equals to in the dual form. And if in the primal form, you see the cost minimization function is given like this. Let me show you. This is the cost function. When the cost function is given, so we need to convert into the profit function, and in the profit function, the inequalities has to be changed. Okay, like this. Profit function and inequality has to be changed from the greater than to the less than. Okay, now let's start solving the first question. That is zx. It is the profit maximization function in which zx equals to 3x1 plus 5x2. So first we need to see in the primal, as it is the primal form. So in the primal form, zx equals to 3x1 plus 5x2. Let's see it is fulfilling the canonical form as well or not. Let's see. So in that, the maximization function, yes, it is a maximization function. Okay, so inequalities has to be changed. Check. In inequalities, you see 2x1 plus 3x2 less than equals to 8. Yes, it is fulfilling the canonical way. Yes, less than. The second one is also 2x2 less than equals to. Yes, so it means it is validating the canonical form. Now let's convert it into the dual form. Remember, in the dual form, we use the another variable, that is y. So the zy will be the cost function. Since it is a profit function, it is maximization of the profit, we need to minimize the cost. So you see 3x1. So x1 has to be converted into y1 and x2 will be converted into y2. So variables has to be converted. Okay, variables has to be converted. And we also know that they cannot be less than n equals to 0. They has to be greater than 0. Okay. You see, the y1, y2, and these are showing the dual minimization function. Okay, now we talk about the coefficient. What are the coefficients? So coefficients, you see, coefficients will be the right hand side of the cost function, right hand side of the constraint, right hand side of the constraint, right hand side of the constraint 8 and 5, right hand side of the constraint 8 and 5 will be the coefficient of the cost minimization function in dual form. So this is the dual form. This is the dual form. Okay, now let's move ahead and we talk about the constraints subject to constraints. So in constraints, you see x1 has to be converted into y1 and x2 has to be converted in the dual form y2. Okay, same goes with here y2. Now it is the minimization function, so you see in the minimization we use the greater than equals to sign, greater than equals to sign. Now we use the right hand side of the constraints of the primal into the cost function coefficient. Now the profit function coefficients must come here at the right hand side of the constraints. So you see, now we talk about what will be the coefficients of the constraints. So coefficient of the constraints has to be find out with the matrix. First we need to develop a matrix of the primal function. 2, 3 coefficient. First coefficient is 2 is here. Second is 3 is here. And over here you see 1. When nothing is written, it is 1. And over here it is 2. So this is the matrix form of the coefficients. So first we need to develop the matrix form of the coefficient. After that we need to transpose it. Transpose means the transpose is what? Transpose is converting row into column or column into row. Got it? So I will be doing both for you just to make you understood my point, that the answer will be same. So if we take it, first we do the column to row. So this is the column. The column has to be converted into row, and this is the another column. It has to be converted into row. So column is converted into row. Now let's move ahead. Let's do the another one just to make you understood the idea that the answer will be same. Okay. Transpose the row into column, the row to column. So you see, this is the row. Okay. So row into column. Into column. So you see, which answer is same? 2, 3 is the row, it is converted into column like this. 1 2 is the row, it is converted into column. So you see answer is the same, so you can take any of them. So let's move ahead. Now you see 2 3 1 2, so you have to write the transposed matrix, that is 2 3 2 3 1 2 1. You don't write 1 2, signs are same, plus. So this is the dual form, and especially remember writing y1 comma y2 greater than and equals to 0. So this is, you have learned the dual form of the linear programming function. Thank you, Anuj.